Okay, so this is 3.2 College Algebra, Example 4, page 184, Graphing and Factoring Methods Combined. Okay, so they give us this equation, and they want us to do the following. A, graphically find one of the x-intercepts of y equals 3x squared minus x minus 10. So you're just going to replace this with a y, plug it into your graphing calculator, and it will spit out your graph. Okay? Now, one of the x-intercepts, if you look at the graph, in fact, they have a picture of it on page 185, right-hand side, top of the page, and they have two places where the graph crosses the x-axis. One is between -1 and -2. We have no idea what that is exactly, but the other one crosses, it looks like, at pretty close, if not exactly, at the number 2. Okay? So that being the case, we can algebraically verify that the 0 found in part A, which is x equals 2, is an exact solution. So all we're going to do is we're going to take this, put it in here, square it, multiply it by 3, subtract 2 here, subtract 10, and we should get 0 for our answer there. If we get 0 for our answer, in this case we do, then we know that our 2 is an exact answer and is an exact x-intercept because y is 0 at the x-intercept. Alright, so C, use the method of factoring to find the other solution to this equation here. Now, the book is assuming that you have read ahead in the book, I guess, because what they're showing you doesn't really come until quite a bit later. So I'm going to just kind of do it the old-fashioned way because that's where we're at. We haven't really learned how to do this yet. Okay, I'm going to put the 0 over there and get rid of that one. And we're just going to factor it. Now remember what I said last time. When you have a number in front of the x squared, a coefficient, you take that number times that number, and we get -30. And what we're going to do then is we're going to look for two numbers multiplied together, give us -30, added, give us negative, I'm going to put the 1 here even though it's assumed, -1. Okay, so what are my chances? I've got options 30 and 1, 1 and 30. So that's negative, that's negative. We also have 5, -6, -5, 6, 10, -3, -10, 3. I mean, so you sit there and look at these and it's like, oh my goodness, the difference has to be 1. So I know it's probably going to be that because the difference between 5 and 6 is probably 1. Let's keep going. We've got 15 and 2, and 15 and -2, and we had 6 and 5. And let's see, anything else there? Can't really think of anything else. So, let's write this as 3x squared minus 6x plus 5x minus 10 equals 0. Because -6 plus 5 is -1, -6 times 5 is -30. Okay, so now we're going to group first two and the second two. We're going to factor out a 3x from there, and we're going to be left with x minus 2. We're going to factor out a 5 there, and we're going to be left with an x minus 2. Okay, so remember when you do this, if these two are not the same, you did something wrong. Alright, so we're going to take this and put it with that. And then the x minus 2 we'll just write one time. And there we go. Now, 2, we already found out that worked. We're looking for the other one. That's what C, the other solution. So that's all we really care about. So 3x equals -5, therefore x equals -5 thirds. And again, that's somewhere between -1 and 2. So there's my two solutions. My 2 that I found in B, and then -5 thirds that I found in C. Okay, if you want to look at the book for part C on page 185 and how they did solution, that's fine, but it's just like this 3x minus 5 just magically appeared. They didn't really explain where it came from, so hopefully that helps you a little bit to understand what's going on. So a key here is when you're just looking for approximate solutions to the quadratic equations that you're given, just graph. And you can just, get a guesstimate, get an idea of what the answer is going to be. It's going to be kind of hard to look at a graph like the one in Part A, Figure 3.1a, 8, top of page 185. That left-hand side, it's hard to guess that that's exactly negative 5/3. I mean, golly, it's somewhere between -1 and -2, but to guess negative 5/3 is going to be kind of tough. So it's just kind of an estimate. But when you actually do the algebra and come up with negative 5/3, that's when it becomes the real deal. All right, so let's jump over to the square root method. What I'm skipping here is just using Excel spreadsheets and your graphing calculator to go ahead and graph that. But if you're going to use those, go ahead and go over that. But it's just some review here on page 187 on the square root method as far as finding out that if x squared equals c, that if you square both sides, you are going to get x equals plus or minus the square root of c. Now the plus or minus is very important here because if I have x squared equals 25, what that is saying is, what number can I multiply by itself to get 25? Well, 5 times 5 gives me 25. And negative 5 times negative 5 equals 25. So, plus 5 gives me 25 and negative 5. So, plus or minus. All right. So, what we're going to do here is we're going to isolate the radical first and then take the square root of both sides. I don't know that the book says anything about that, but let's go ahead and do it that way because that's the way I was taught. Isolate the radical means get it by itself. Oops. Okay, now it's isolated. I mean, not isolating the radical, isolating the exponent. Then I'm going to take the square root of both sides, and as soon as I do that, I get a plus or minus. So x equals plus or minus the square root of 8. Okay, but that's not good enough. Square root of 8 can be reduced. All right, so how do you reduce a radical? You write out the factors, prime factors, and whenever you have 2, they get to leave the house. That's what I teach my high school students. They can leave the house as one pair of 2s, leaving me with 1 left over, and he stays inside. Okay, so that's the reduction of the square root of 8. Now that should be old stuff to you, so I'm not going to go into explaining all of that. All right, so let's look at part B, and we've got x minus 6, the quantity squared, equals 18. Take the square root of that, square root of that, and we get x minus 6 equals plus or minus the square root of 18. I'm going to add the 6 to both sides, and I can reduce the square root of 18. So let's do the prime factors. I've got a couple, they can leave the house, and the 2 is all by itself, so it stays in there. And that's what it looks like. Okay, so completing the square, which is example 7. Completing the square is one of those things that becomes very, very handy, but it's a little bit hard to remember all the steps in order to do it. But let's just kind of give it a shot here. There are going to be some times where you can't factor because the factors of the equation or of the quadratic equation are going to be so weird, like fractions or something, that you just can't factor it. So we come up with a way called completing the square. We also have what is called the quadratic formula, which we'll get into in a minute. Completing the square is very handy for lots and lots of other types of algebra, so it's very good to use it and to be familiar with it, although you'll probably use the quadratic formula if you have the choice. All right, so how do we do completing the square? So again, we're looking for x. So what we're doing is we're going to try to make this a perfect square, so it's a heck of a lot easier to solve than this messed up thing we have here. So first thing we do, keep all the x's on one side and make a big space, move the 7 over here by subtracting it from both sides. We are going to look for a term to put in here, a third term. And where we find that is we take half of this number and square it. So half of 12 is 6, and we're going to square it, and it's 36. It will always be a plus because we're squaring. Whatever number this is, half of this is negative 6. Square negative 6 times negative 6, you get positive 36. But we can't just add a 36 to here. Okay, we're saying that this here in black equals negative 7. Now we're saying this here in black plus 36 equals negative 7. No, that's not true. We just added 36 here. So it's no longer equal to this. Unless, of course, we add 36 to this side too. Now they're equal again. Okay, so whatever you do to this side, you have to do to this side. If you add it, subtract it, multiply it, divide it, got to do the same to both sides. All right, so now we're at a good place. I'm going to go ahead and write this out again and solve for the right-hand side. And this is going to be 29. Okay, now what we're going to do, and again, this always works, I'm going to make a parenthesis. I'm going to put an x here. I'm going to take the square root of that, and I'm going to take this sign and put it here. Okay, I didn't do any math at all. Nothing weird. And then I'm going to put an exponent there, equals 29. That's the way you always do it. Square root of x squared is x. Square root of 36 is 6. This sign goes here. Squared goes there. This number comes down. Okay. Now all we have to do is square root both sides. And we get x minus 6 equals plus or minus the square root of 29. Add 6 to both sides. And there's our answer. That is why you didn't want to try factoring that, because you weren't going to come up with that for an x by just factoring. Okay, so that is it for completing the square, and we will go with 3.2c for learning the quadratic formula.